So good morning, everyone. Today we're here to talk about steel and specifically the renewable nature of steel in our industry. And to help us on this discussion, I'm really pleased to be able to introduce you to Matthew Teague, who is the Market Engagement Manager for TATA Steel Building Systems, and the ideal person to talk to us around about how sustainable steel actually is and how we in the industry can make the most of this very precious resource. So Matthew, good morning.
Good morning. Morning. Nice to be here. Thank you.
Great. Well, let's start off with, why don't you explain to us all what a market engagement manager actually does, and then we'll kick off with how we measure carbon and the like within steel.
Yeah, I mean, it's a very broad role. I don't think my particular role covers what, if you Googled market engagement manager, I guess it probably wouldn't correlate too closely. It's to do with market intelligence in my role, sort of what the market is doing, particularly at the moment around new legislation and how that will affect my industry, or my part of the industry, the part that's looking at sort of composite panels and things that go on building. Things like the Building Safety Act, which come along post Grenfell, is obviously going to have a big effect. Changes to Part L, potential changes to Part B of the building regs, that sort of thing. And then, so it's a two thing. It's actually finding out what the market and people in the market think that means, and then feeding that back into the business. Also, any consultations that are coming up, tend to get involved with that. And then there's a sustainability aspect to the role as well, mainly because we've got no dedicated sort of sustainability resource in the business at the moment. So a few of us pick up that remit, and sort of spread it between roles. But that's probably perfectly acceptable. Being just sustainability is a really, really important subject, and it shouldn't be just down to one person to dictate that. It should be everybody's role and sort of concern.
Yeah, I think that's absolutely right. I think sustainability requires many hats and many people to arrive at the right answer, doesn't it? And if we get a chance, I think we'd love to explore the Building Safety Act and TATA's response to that, because I think that's another really interesting area that would be worth exploring.
Yeah.
So let's start with sustainability, and one of the challenges I think we all have is, how do we measure embodied carbon within our products, and how we're going to be forced, I suspect, into doing this for whole buildings. How's TATA tackling this to be able to provide us with the information in the industry that we're going to need to be able to do this?
Okay. Well, we've always measured embodied carbon. We measure everything, it's fair to say. Embodied carbon per ton of liquid steel out of the plant at Port Talbot, as of Monday, was in the region of 1.6 tons. So in world terms, it's about 2 tons. Rule of thumb is 2 tons of CO2 per ton of steel. From the blast furnace route, there are ways of producing steel which considerably reduce that figure. So, and that's part of the reason for South Wales and also British Steel at Scunthorpe transitioning to electric arc furnaces rather than the blast furnace route. So, but embodied carbon is measured by sort of the amount of CO2 that comes off our process, and then any post-processing, post-liquid steel stage, so processing steel into coil, processing that coil into something else. There are also additional aspects of process which add embodied carbon. Transport being one of them. Extra furnaces, if you're heating steel up again, there'll be embodied carbon involved in that. But I guess the point is that historically we've been reducing embodied carbon throughout the way we've been making steel from iron, melting iron ore into iron and then turning that into steel. That line has been going down for many years, arguably since the process began. We've kind of reached the limit of what's technically possible now, I think.
Mm-hmm.
And so the other technologies that have been mooted to reduce embodied carbon by, for instance, taking blast furnace gas and putting it under the ground somewhere, carbon capture and sequestration, or carbon capture and use, or a combination of the two. I think those particular solutions are technically incredibly expensive and probably several years away.
Mm-hmm.
So the technology which exists now is electric arc, which is where we're moving to. Embodied carbon is declared in environmental product declarations, EPDs. So we produce EPDs for everything we make, right from a coil of steel to a finished panel. So you can have an EPD for everything we make. And that will declare not only the carbon, but also lots of other things, lots of other greenhouse gases and energy, that sort of thing. So it's a very comprehensive document.
Brilliant, Matthew. Lots to unpack there, but let's work backwards a bit. The EPD and is something which is becoming far more available within construction as a whole. Could you sort of explain to listeners how effective they are and what the efficacy is? Because we see EPDs coming from overseas as well as the UK. Can the industry have confidence in the information that's published in those unilaterally, or do we need to look closer at who's doing the certification of those?
I think it's sensible to look closely at who's doing the certification. Our EPDs are underwritten by external sort of accreditation verification, because we believe that the information is so important now that people should have absolute confidence in it. And we have a very, very, very good sort of world-class team that puts the EPDs together. Been doing it for several years, so I think it's fair to say that we have world experts in measuring the various aspects of an environmental product declaration. Not all EPDs are created equal, however. So there are some providers, I won't name them, but there are some online providers, for instance, for whom we know that the information contained in those is not up to date. For one, is potentially inaccurate in others, and there needs to be a way of sort of bringing. Well, there are standards, of course. There are standards for EPDs, but again, the accuracy of all EPDs is not necessarily the same. It's worth checking, worth making sure that the information is up to date, is trustworthy, and your members can sort of proceed with the knowledge that the EPD is the best that they can get. Obviously, some figures in EPDs are gathered, from databases, which you're relying on the accuracy of the database. That's just a fact of life. But we measure everything that comes out of the plant is measured by us, so we have a very high degree of confidence in the figures that we put out.
Brilliant. Okay. I mean, I think that's it's increasingly important as to how we get there. And what you're saying is we're getting, so technically we're using about as the energy that goes into making steel, we're about at the most efficient or most effective. We're not going to get much less energy into steel to produce what's required. It's then what we do with the stuff around that creates. Is that what you're saying?
Well, the process. So there are several processes now for making steel, but the two main ones are blast furnace basic oxygen, which is dates from Abraham Darby up in Coalbrookdale. That the technology, the way that reaction works chemically hasn't changed. It's just we've just got more efficient at controlling and inputting into it, and sort of there are kind of laws of diminishing returns come in all the time. So, the blast furnace hasn't changed a great deal in its shape and its function since it was invented. There have been changes to the way we make steel from iron. So, sort of Bessemer invented the Bessemer converter, which blew air through the liquid iron, which then converted it to steel, by taking more of the carbon out of the steel, out of the iron. And then there's a process called the Linz-Donowitz process, which is pretty much what most modern steel makers use now, which blows oxygen through. So it's a more aggressive way of removing things from the iron, and that's pretty much what everybody does now in the basic oxygen furnace and basic oxygen steel making. So the technical advances, there are some continuing technical advances. So in Holland, in our sister plant in Holland, we've got something called Hysana, which is a low carbon steel making, which is like a converter which takes takes coal, so you don't need coke. It takes iron ore, and you sort of put it into this converter, almost like a cyclone, almost like a sort of massive steel making Dyson. And you heat it up in much the same way that you heat up a blast furnace, but the end result is you get about a 30% reduction in carbon from that. Yeah. So that's one way of doing it. And then there's hydrogen steel making. So there are the companies in Sweden, places with abundant hydroelectric resource, usually because you need a lot of electricity to make the hydrogen, and that hydrogen as a reductant is very, very efficient, and just kind of replaces a lot of the coke and other carbon emitting substances that we use in the blast furnace. So that's things like hybrid are now on the market, but mainly for automotive. I think Volvo have bought most of the production from that plant for the next so many years. Okay. So it's green steel. It's beginning to become more mainstream, sort of from direct production. The electric arc has been around for many years as well, and that melts scrap. Yep. So we can obtain steel from steel that's been previously made, with another great reduction in emitted carbon. So whereas you're looking at about two tons per ton from the blast furnace, you're probably looking at more like, so some of the very efficient ones are very low in terms of kilograms per ton, so 300 to 600 depending on the efficiency of the EAF. Yeah. And also other, you can capture gases from it as well. So we will be looking at a huge reduction in the emissions from Port Talbot when the electric arc furnace comes online.
Mm. So, and is the electric arc furnace going to be using green energy, do you think, from all those solar farms and wind farms on South Wales? Is that the plan?
Yeah, one would hope so, yes. I mean, absolutely. I mean, the lower emission ranges of electric arcs are predicated on the use of renewable electricity. And that's, yes, I mean, that's the plan, to buy as much renewable energy as we can. Yeah.
So is that going to create challenges for the industry then? Are you going to be able to issue very low certificates when the wind blows, and high your EPD for when there's no wind and no sun? It's going to be higher, is that, or are you going to equalise those out over a year's production? It's really sort of interesting sort of questions around how that works.
You would have thought that would be equalised in some way, or the renewables would be obtained through, I don't know, regoes or something like that, which would allow you to amortise that across the year. I'm sure there are, well, I know there are cleverer people than me looking at things like this right now, and how that actually works. Yeah, I imagine it's inconceivable that you'd have a variable EPD for steel coming out. I think that would just confuse everybody far too much. Yeah.
I think it would. I mean, green steel has been much vaunted over the years. It sounds as though, Matthew, we're beginning to get somewhere close to it. We can get down to 300 kilograms a ton. Is there a sort of a description? Does Tata have a description for green steel for what it's trying to achieve, or is it still one of those sort of concepts in the air that everybody refers to, but without a definition?
Yeah, I mean, I think green steel might be, an unhelpful definition in many ways. It's shorthand for low carbon steel, and I think that's a phrase we would probably prefer. Right. Low carbon steel, because or low emissions, whatever. Low carbon steel would, might mean something else to someone specialised in metallurgy, for instance, having less carbon in it than something.
Well, absolutely, yes.
It's and the design of the arc furnace, the way it sort of it works, and the energy mix, I guess it's designed for a particular emissions range. Remains to be seen what that actually would be, I think.
Yeah. So the electric arc furnace coming into Port Talbot then is really going to rely on recycled or recovered steel.
Yeah.
Are Tata going to be doing anything to help the industry recycle the steel that comes out of demolition and other areas? Because the recycling is becoming an upcycling is going to be far more important as sustainability takes even greater hold on our operations.
Yeah, I mean, they're already within the industry. There's a group called Circular Steel, which is very active in promoting reuse of steel, reuse of structural steel in particular. It's a construction-based group that has, I think, great potential for certain uses. Notwithstanding the fact we still need scrap to go into a melt in the arc furnace. The quality of steel is very important. So the scrap that goes in to an arc furnace needs to be free of tramp elements, things that we don't want in steel. So you have certain requirements to try and reduce as much as possible the amount of copper that goes in. Copper's unwanted in the mix. So are a few other elements, but so we sort of everybody that's planning to do this is already talking to metals recycling companies to talk about the quality of steel going in. So that there are ways that you can add something called DRI, or it's direct reduced iron into the electric arc as well, and that's often made by blast furnaces. So you can have a dual route strategy, if you like, that you're still running blast furnaces or you're getting DRI from somewhere which is. And that can be added to an electric arc to sort of change, to adjust the mix. Again, that's not my particular area of expertise, is the metallurgy and the way that the stuff in an electric arc works. But I know that we can produce almost all of the grades that we produce now out of a blast furnace. We can now get from an electric arc. And that's largely because of a lot of work done in the States, where they run, quite a few more electric arcs than anyone else. A company called Nucor, in particular, did a lot of work on the metallurgy of steel out of electric arcs, and managed to sort of up the game really for electric arcs. So it's become, whereas before you're sort of getting fairly low quality steel, which was mainly used for things like rebar. You're now getting the stuff that can actually go into cars and buildings, and sort of high quality, high strength steels, that sort of thing.
Brilliant. So I mean, if you're looking for this high quality steel coming back again, so particularly structural steel you're talking about there in cars, is it going to, I suppose, what sort of tonnage are we looking for to run the electric arc furnaces that you're running? And is that going to push the price of steel up, or scrap steel up further, so that we've got a more incentive to recycle off our construction sites?
Hard to say at the moment. I mean, at the minute, UK produces, I don't know, about 10 million, 8 to 10 million tons of scrap per year. We export most of that. So a domestic market for scrap is entirely possible. Market forces would suggest that perhaps there would be some fluctuation in the price, but again, I strongly suspect that we are already talking to people about that.
Yep.
How the streams would need to adjust, because obviously we're moving from exporting scrap to essentially keeping it within the bounds of the UK. So transportation costs, you'd imagine, would come down. Our emissions from transport elsewhere would come down. We're not re-importing steel made from scrap that we exported back into the country. So, there are some potential benefits in having, if you like, almost a closed system within the UK. And there have been a couple of reports by Cambridge University. A guy called Professor Julian Allwood has done a couple of reports for UK government, amongst others, about the scrap routes, the amount of scrap in the UK, how that system could work to maintain a domestic scrap-based steel making organisation. Yeah,
brilliant. So, I mean, Matthew, so to paraphrase what you've been saying, we should see a sort of, it's not quite an order of magnitude, but a significant reduction in the embodied carbon coming from blast steel furnace to electric arc furnace steel that we've got within the sector. So that'll be it'll help us reduce the embodied carbon within the buildings we're producing, and we will be able to, particularly if we get full carbon accounting coming in, that's going to be able to reduce everybody's costs down if we're having to account for the carbon potentially being taxed on it. That's really good news for us all. And it sounds as though if we can get this circular economy within the UK, then actually recycling what we have and trying to keep that within the, if you like, the steel circuit, sounds like it could provide a real opportunity for all of us within the sector to keep our carbon concentration down. And we affect 40% of the UK emissions, don't we, within the industry?
Yeah, absolutely. And it's also quite interesting to note that the pilot copy of the UK net zero carbon building standard came out last week. That's got targets for embodied carbon per meter squared. For sort of quite a few sectors, which are quite ambitious. So by 2050, we're down to sort of double figures only embodied carbon in most building types. So you would have to think that, or hope that the trajectory, rightly, if you want net zero carbon by 2050, everybody's got to, if you like, sort of think about this very hard each time we go out to site or design a building or whatever place in the sector we have. We all contribute to it, and part of that contribution has to be where the raw material comes from and how it's made. And if the option exists to obtain steel direct from a demolition site and reuse it in another building, that's one way of reducing your carbon. If the option exists to get your what I'm suggesting is there's probably going to be a hierarchy of source, if you like, in the future, which people will naturally go and see if there's something which they can take, which has been previously used, or even if it's already in the building. Of course, there are quite a few buildings where whereas previously you would take a frame down if it was there and start from scratch. You're now reusing that frame. There are several contractors I know which have more than one building, and they're working on. One's a donor building which is actually supplying steel to the next, to the other one, essentially just repurposed off the demolition site, which we should start calling the disassembly site now, I think, probably. Yep. And then you would go to green steel, not virgin steel, but sort of steel from an electric arc. And undoubtedly there would be probably some cases where your source is still from a blast furnace in certain very, very very, very specific uses. Probably not in construction, probably in automotive or defense or something like that. But that would be tiny amounts compared to what it is now.
Brilliant. I mean, one of the areas which I know you're heavily involved in, Matthew, is systems building, and presumably, would you like to talk a bit about what TATA are doing to reduce the carbon, but through design of those systems?
Sure.
Because I think that's important for people to understand. There's a lot of work done by designers and manufacturers to reduce carbon through design, not just through the materials.
It's the other leg of it, I guess, is that touching back on that idea of sort of using a building almost as a warehouse of its own parts, which a colleague of mine, is a great phrase that he invented. So the first question a designer should ask is, do we need to build?
Yeah.
Can we refurbish, or can we do something with the existing building? The second question is, what's the extent of that building? How much stuff do we need to make that building? So how efficiently can we design that building? What materials can we use which reduce the footprint of that building? All of these are questions which we should be asking. Balanced with what's the performance of that building, I guess, because there's a definite two-pronged sort of way of looking at that, is that you might decide to spend a bit more embodied carbon at the outset of a project in order to save its operational carbon later on, and there's always going to be a balance struck there, I think. And then in terms of systems, I mean, systems is often wrapped up with the idea of modern methods of construction. I think we're now favouring the term industrialised building, but it's basically a mixture of volumetric modular for certain. That's always been touted as the next big thing for since the 60s. It's always been the next big thing. It's very appropriate for certain types of buildings. So cellular, bedrooms, hotels, barracks, that sort of thing. That modular's great. Lots of schools and hospitals using systems as well. You've got panelized, so quite a lot of hybrid, part volumetric, part panelized buildings. And then we've recently done a lot of work on design for manufacture and assembly in construction and platforms, kits of parts for buildings. So it's nearly a couple of years old now, but the office building on the south bank of the Thames, the Forge for Landsec, that was a kit of parts that we were involved with, and as a manufacturer, it's really interesting work to be involved with, because the sort of philosophy of it is that you take something which is already made or is manufacturable, shall we say, and then you incorporate it into the design. You don't do what a lot of designers and architects have in the past, which is sort of have an idea and then go and find someone to make it. You're actually sort of looking at what's available first, which is because something's already in manufacture. That's quite an efficient way to to design something.
Yeah. So Matthew, you talked there around about reducing the materials or the embodied carbon within some of the products that Tata produce.
Mhm.
Are you looking at how those might be recycled at end of life and taken out of the building, so they're not, they're more easily extracted out of a demolition as well? Is that part of the remit that you're looking at?
Yeah, definitely something. I mean, yeah, absolutely. And in terms of the sort of profiled steel that we make, the panels that we make, the end of life recycling has always been something of a challenge. There aren't very many people that take those sort of composite materials and recycle them. However, that's changing now. There are a couple of companies that are doing it. I came out of fridge recycling actually originally, so it's the same sort of foam used in a fridge. They'll take the blowing agent out of the foam. We have been looking at ways of recycling, various elements of the panels we make. It's fair to say that it's very early days at the moment because a lot of these technologies are embryonic or, sort of pilot scale. But it is possible, and it is something which we will, need to look at in the future. Things like take-back schemes, for instance, for panels, so they come back to base to be dealt with rather than go to landfill or something, something worse. And also, the other side of this coin is that because we will be operating electric arc furnace in the future, having the stream of your own stuff coming back is actually very helpful now. So if we can actually get that that flow of material we know is ours, material that we know has a particular composition pedigree, so we that could then go straight back in without sort of needing to be sifted or tested or whatever.
I mean, Matthew, Tata have always been at the lead of doing a lot of this. As you said, you've been measuring everything forever. Is this common throughout the steel manufacturing industries around the world, or is this something that Tata prides itself on as sort of being best in class?
We're really good at it, and we certainly would suggest that we are best in class. Everybody certainly in the developed West, will be measuring pretty much everything they do, their emissions, their inputs, etc. I can't, I don't think
modesty precludes you. That's fair enough. I mean, I think we know we've had challenges on, if you go back in time, there are some staples that we've had real concerns over quality coming in from imports. And I'm aware of how hard Tata works for ensuring the quality of their products, certainly in the UK. It's an area of concern when we're designing things to the absolute limits, both in terms of carbon, but also in terms of structural design.
You don't know what
we have confidence in what's been delivered, and that's a key aspect for it. But I think that's there.
Well, as you know, I mean, not only would you have the the EPD accompanying a product, you can also get the take it right back to the coil it was made from, the certificate for that coil, should you wish to do so. So everything down to the composition of that particular piece of steel, its its strength, its grade, we can supply.
Yeah, well, and it's not just steel, is it? I mean, the same thing's happening in farming. You have to take it right the way back to square one, and I think this traceability is becoming ever more relevant to our industry. It is. So, I mean, I think let me ask you sort of differently. How optimistic are you about the UK construction sector reducing the carbon of its buildings over the next 5 years? Is that something that sounds like Tata's got a major part to play in?
Yeah, well, as a materials provider of one of the main structural the main structural material for a lot of buildings, shall we say? Absolutely, but in terms of a sector, yeah, I think sort of it's massively on the radar of everybody now. I don't know of a, sort of going around architectural practices. I would say it's front and center now of everything they're doing. That and fire.
Yeah.
Yeah, almost certainly. So it's sustainability, the carbon intensity of a building and fire are the two main things. If you're designing buildings, building buildings, those are the two things on your radar, I would suggest at the minute.
Well, that's a great segue to come through to the results of the Grenfell disaster. We're still sort of reeling from the implications of that. We've had the public inquiry published. What's Tata's response been to it for their elements of buildings that the materials that they're providing into buildings? What's been keeping you awake at night to solve those problems?
I don't think anything's keeping me awake at night because we never have provided sort of panel products into high-rise resi. So most of our product goes into warehousing, distribution, that sort of thing, big sheds, which by their very nature are single story. At the most they've got a mezzanine in them. Escape is a relatively sort of simple proposition. You just run out through a door in the side of the building. Having said that, I mean, high rise or high risk buildings, they don't have to be residential. Hospitals and other sort of classes of building fall into the high risk category now. It's not necessarily going to be an easy thing to navigate. I think for a lot of designers, a lot of contractors, and insurers as well. I think.
Yeah. Well, I would say I've experienced that at the sharp end, driven by insurers, particularly on a fully sprinkled building, and the insurers just drew a blank and said, "I'm sorry, it's going to be rock wall or nothing." That's the answer.
Yeah, well, there you go. On a fully sprinkled building, arguably, it's belt and braces. It's going to be tricky to, I think, for a little while, whilst people get their heads around what the Building Safety Act, what the Grenfell report actually, what actually comes out of it in terms of the revision of certain things. We know that the Building Safety Act obviously came out of Phase 1 report. The Phase 2 report has some more recommendations in it, which includes a root and branch look at the building regs and an overarching building regulation function, whatever you want to call it, but a single controlling mind over all of these aspects of building regulation, which will be disruptive probably for a while, whilst people get their heads around what that actually means.
Are you providing different information as a result of the Building Safety Act to designers, or are you really waiting to see how those designers are going to respond to the requirements of the Act?
We're currently rewriting a lot of the brochure stuff, the online information on products, taking that into account. We've got a very, very full program of fire testing, still, which is ongoing. We're kind of testing all the time. We're going to have to look at that in light of what comes out and what we need to do in the future. There's some suggestion that the large scale test, what's known as the BS 8414 test, will become, well, I'm going to say probably not mandatory, but almost an advisory thing. You should do this. That's a very expensive test, so quite how that's going to fit into who's going to pay for it, when it's going to be done in the sort of design process of a building, in that sort of timeline, who's going to do it, when it's going to be done. There are lots of imponderables, lots of questions that are thrown up by the report.
I mean, those sort of tests will probably be driven by insurers, and it may well drive consolidation within the sector, as only the larger operators can actually afford to provide those to undertake those tests, because as you say, they're enormously onerous and long-winded and expensive. But if they provide the guarantees or the insurers are going to be looking for, that might well be the backdoor way of doing it. We shall see. We'll have to wait and see.
Yeah, and we already do. I mean, sort of insurance testing. So LCPB and FM have their own regimes, which we also test to, which are, arguably the FM regime is more onerous than the British standards regime. We'll see how it pans out, but it will definitely have an effect.
Yeah, so it'll be driving more process and possibly more cost into everybody. Matthew, we've had a great tour of sustainability and a bit about safety. What sort of final question which is probably a bit unfair, but if we're looking at sort of contractors who I always think are sort of the fulcrum in the industry between client and trying to manage the rest of the industry in terms of suppliers and design, given the changes you're seeing both in sustainability and safety and fire safety, what would be your message to that sort of cohort of people who have to sort of manage both the expectations of clients, the performance of buildings, and the supply chain to deliver it? What would you also? You're going to have a message of hope or a message of just work harder and hope it all works out?
I think it is difficult being in that position at the moment. We've seen some high profile insolvencies recently, which is most unfortunate and quite worrying for those of us in the sector. But I think if contractors can move with the times and take on board the sustainability message in particular, then I think there's a very bright future for the sector. I think we're always going to need buildings. We're always going to need buildings, new buildings, repaired buildings, improved buildings.
Yeah.
It's not a case of this is we're ringing the death knell of contracting at all.
No.
But certainly, there are challenges. There are challenges for in terms of skills, workforce, adopting new technologies as they come along. But there's if you only need to walk around a thing like Construction Week to see how many new things there are coming along, and things like platform construction can aid the work, the workload, and to a certain extent address the skills shortage. There's recent advances in robotics, so making certain things safer. So there's lots to be hopeful about, as well as the various health warnings that came out with ISG last week, the week before. So I would say I think it's a challenging but exciting time. A bit like that Chinese proverb about living in interesting times, isn't it?
Yes.
It's definitely interesting times, but I think there's a lot of reason for hope, because looked at in one way, net zero is putting a burden on all of us to change and to alter our behaviour. But on the other hand, we are actually addressing the climate crisis. We're actually doing something about it now, and that's really, really good news for the planet. Hopefully. So I think there's good reason to be hopeful about the future.
Brilliant. Well, I think on that note of optimism, Matthew, I'm going to say thank you very much. It's been a fantastic whistle-stop tour through the areas of sustainability and fire, and particularly looking at one of the core products we have that facilitates construction. I mean, without steel, we wouldn't be anywhere. And it's great to see the work that's going on within TATA to reduce that carbon footprint down of steel, and the work that's been done to create a circular economy within steel within the UK. I'm sure everybody very pleased to see that. So thank you very much, and
thank you.
we will look forward to making everybody aware of the message. Thank you.
Thanks, Mark.